QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. Let's consider this given quadratic equation. Is the trinomial on the left-hand side factorable? Yes or no? The answer is no. So since it's not, what should be the constant to be added on both sides to create a perfect square trinomial? The constant should be 9. And with this, what are the roots of this given quadratic equation? The roots are square root of 6 minus 3 and negative square root of 6 minus 3. Did you get 3 over 3? If not, please continue viewing this video. In our answers a while ago, especially on the roots, we have a radical expression. This is made possible whenever our quadratic trinomial is no longer factorable. Let's try to examine it step by step. Our coefficients here for A is 1, the B coefficient is 6, and the C coefficient is 3. Now these are the 3 coefficients and they are all present, therefore we drop the method for extracting square roots in the common monomial factoring. And again, we are not yet using here the quadratic formula, so it's either factoring and completing the square method. We can identify whether we use factoring or completing the square method by looking into the consideration whether this trinomial is factorable or not. If it's factorable, it should follow this concern. A times C, 1 times 3, so you'll have here 3. If we could look for a pair of factor for 3 that when added will result to your B coefficient, then the answer is yes, this is factorable. And we can use factoring. But when you look closely, the factors of 3 are 1 and 3 and negative 1 and negative 3. Because 1 times 3 is positive 3, negative 1 times negative 3 is also positive 3. These are the 2 factors, or 2 pairs of factors rather. If we are going to add both of them, 1 plus 3 is 4, negative 1 plus negative 3 is negative 4, neither of them will reach 6. This would mean this is the support that this given trinomial is non-factorable. Okay? Again, non-factorable because there's no way that the factors of your AC when added will result to B. And if this is non-factorable, we are going to use the completing the square method. What square does it mean? The completing the square method is actually a process of allowing us to create a perfect square trinomial. Because once we have a perfect square trinomial, number 1, we can now factor the trinomial. And of course, we can proceed with the rest of the steps using factoring that will allow us to solve for the roots. But then again, we cannot do that here. This is non-factorable. So we are going to complete such square. The task here is this. To complete the square, we just simply need to change the C coefficient. That's the only thing that we can change. Okay? In short, let us try to move that out on the other side. Okay, so 6x. When we move the 3 on the other side, you have minus 3. And we are going to add something here, a new c, new value of c, in such a way that this resulting trinomial would be a perfect square trinomial. And what would that c be? Let's try to use c sub 1 so that we can actually compare it with the original c. The c sub 1 that we are going to use is the square root of the value of getting b divided by 2. Okay, we're going to divide the b coefficient by 2 and multiply with the square root of a, and after that we take its square. But usually some of the formulas doesn't use square root of a, but since because they don't use square root of a because here our a coefficient is 1 and square root of 1 is just 1, right? But there are some instances like if the a coefficient is also a perfect square like 4, 9, 25, so it's better to have something like this. We're going to input all the values here so that we could decide the correct c that we are going to add here to complete such square. Now, don't be confused. We're going to do this step by step because this is a very lengthy process. Why? Because first and foremost, we cannot use extracting square roots. We cannot use factoring. So we end up with completing the square. So of course, these steps are longer than the steps or the methods before. So we are going to take extra precaution in solving for this. So you'll have here this, the value of base 6, divide by 2, square root of a, which is 1, and you take the square of it. So you'll have 3 squared. And the correct value for c that will allow this, when added here, will allow this expression to become a perfect square trinomial is positive 9. Okay, positive 9. That's the value we're going to add here. So x squared plus 6x plus 9. Okay, we added 9. But please do not forget to do the same thing on the other side. Okay, to retain equality, because that is for the properties of equality. Now that we have a perfect square trinomial, we can do this now. Once we have a perfect square trinomial just like this, we can take, okay, a perfect square trinomial is a result of squaring a specific binomial. And that binomial is square root of the first term, not just coefficient term, x, square root of the new c, 3, and the sign of the middle term, plus. In short, x squared plus 6x plus 9 is just the square of x plus 3. Again, x squared plus 6x plus 9 is the square of x plus 3 again. If you have a perfect square trinomial, after adding the correct c, take the square root of the first term for the first term of your binomial. Take the square root of the third term or the last term for the second term of your binomial. Use the sign of the middle term plus, of course, if this is minus, then you will use minus, and make use of square. If you're not sure, you could always take the square of this, and I am quite sure you will return to this perfect square trinomial. Okay, but we're not yet done. This is equal to negative 3 plus 9, 6. Okay. The completing the square method, which follows these specific steps, started with, of course, we've identified whether it's non-factorable or not, or factorable or not rather, so we decided already it's not. Completing the square, looking for the correct value of c. We have the perfect square trinomial and the square of a binomial. This now follows extracting square roots. And take note that when we extract square root of a number, plus minus. So that becomes x plus 3. It's only x plus 3 because the square is already gone. Is equal to plus minus square root of 6. No need to get the exact value. It could be like that. And of course, x is equal to plus minus square root of 6 and subtract 3 on both sides. Okay? In short, these are your roots. And as mentioned earlier, we expect radical expressions. Your first root is positive positive square root of 6 minus 3. And your second root is the negative of square root of 6 minus 3. These are now your two roots. As mentioned, the process is a bit longer and we expect radical expressions since the original quadratic equation is non-factorable. We could also have quadratic formula to check this one, and I know for sure you will get the same results. So these are the entire processes. Again, we started with whether this quadratic trinomial is factorable or not. If it's factorable, then we could use factoring. Okay, that's a more comfortable process than this. But if it's not, just like this, completing the square, meaning we are going to complete such square, we use another c. So we move out 3 to the other side. Once we identify the correct c, we add them on both sides. Now that we have a perfect square trinomial, we reduce it to the square of the binomial, and then we take the root of both sides and end it up with this result. So these are all the discussion for this QuadQuiz. Subscribe now.